Hello, everyone. Good morning, good afternoon, good evening from where you are coming from, right? I'm really happy to have all of you here. Um, I I expect that I can bring some value to you in this webinar. So, just a quick introduction about myself. My name is Rafael. I'm a mechanical engineer and I work as an internal commercial manager at WEG Middle East, which is a commercial unit of WEG located in Dubai, United Arab Emirates. And we are responsible for the sales of for the entire Middle East region. Okay. So again, I'm really happy about today's session. I'm happy that you could reserve some of your valuable time and stay here with us, and I expect that I can prove it worth it and I can bring some value to you as well. Okay, so just a few instructions. I believe these points are already disabled, these configurations here, but it's important to mention to keep your webcam off at all times, just to keep the connection a bit more stable, to keep your microphone muted, okay? However, we are totally open for questions. We have a Q&A part in the chat. Feel free to ask questions at any time. We have a team, we have engineers ready to answer your questions. And in the end of the presentation, I will also go through some of the questions. And it's important to mention as well that in case we are not able to answer your question during the presentation or at the end of the presentation, we will take note of all the unanswered questions and we will contact the people after the presentation with a proper answer. Okay. Now going through the agenda very briefly. So we will start talking a little bit about the importance of the smoke extraction system, where we can find the smoke extraction motors, right? Because these are motors we don't usually see. They are not very easily exposed. So many people are not aware of where you can find this type of motors. Then I will go a little bit in more details about the smoke extraction motor from WEG. So the key features, the specifications, some options we have, and then we move a little bit deeper into the technical part to understand how it works in terms of heat exchange when you have a very hot environment in comparison to a normal motor in a normal operation. Okay. Then I will talk a little bit about the capabilities at WEG, all the engineering, all the laboratories that are behind such development. So there is a very strong engineering behind this line. Okay. Then we move to, I think, the most important part of this webinar, which is the certification process, how this motor can be certified along with the fan or the product from the fan OEM, right? And we end the presentation with showing and highlighting the importance of the partnership between the motor manufacturer and the fan manufacturer. With a good partnership, you can solve 90 to 95% of the issues and you have much higher chances of succeeding the tests. Okay, then we end with a Q&A session and with some closing remarks. So before I go into the main topic of the presentation, I know that some people here are from WEG, some people are customers of WEG already, but I will just briefly show some numbers of WEG to show how big the group is nowadays, right? Either through organic growth or acquisitions. Today, the WEG has 66 manufacturing sites in 18 countries. We have distributors in more than 120 countries. More than 47,000 employees in the world, right? And out of this number, around 10% consists of engineers. And the number I like the most is hiding behind my head, which is the amount of motors we manufacture per day. So WEG can manufacture more than 76,000 motors per day. Okay, this is very, very impressive. And to support this, to make this possible, we also count with the largest industrial plant for LV motors in the world. So in the south of Brazil, we have a manufacturing plant with more than 1 million square meters. Okay. And this is only one of the plants, but for sure it helps reaching this number of more than 76,000 motors per day. Okay. Okay, a brief introduction about WEG. Now let's go into the main topic of this webinar. So what is a smoke extraction system and where can you find the smoke extraction motors, right? So when you look at this type of environments, when you look at closed locations such as tunnels, subways, or maybe a shopping mall, car park, you have closed spaces with a huge amount of people. So you have a lot of people walking or maybe driving their cars. And these are the places where we can find the smoke motors, okay? Now, just imagine you have a situation like this in the video, right? You have a tunnel and then you have an accident with a car, a truck, or any accident you can find, and you have fire. So the fire is very dangerous for an amount of reasons. You have the toxic gases, you have the carbon monoxide, which is very, very dangerous for us humans. We have the extreme heat, right? We can start compromising even the structural part of the tunnel in this case. There is the visibility issue. If with the amount of smoke, it can cause even more accidents, right? So it can cause a chain of accidents and increasing the risk significantly. So if you look on top of a tunnel, you have these ducts, right? And this is where the magic happens. When you have a fire in a situation like this, when you have an emergency, there is a smoke extraction fan, okay, which is manufactured by the fan OEMs. And these smoke extraction fans, they have as a main component, let's say the two main components of the fan are the fan itself, the impeller, right, which I'm showing here in this part, in the front part. And in the back, and a little bit hidden, you can see the electric motor, right? In the beginning, I said that usually we don't see these motors. They're not very well exposed, but this is the reason. They are usually found inside a fan casing, inside a duct like this one, where we can see only the blades, right? The blades of the impeller. So WEG has a very extensive expertise in the smoke motors, right? We have tested already several different motors in various configurations with the certification bodies, right? In Europe, for example, in US. So, and we have developed many partnerships with fan OEMs during these years. So this is in summary what the smoke extraction application is about. So you have a smoke, you have a fire in a place where you have people, in a place where the smoke cannot leave the space naturally, and then you need an electric motor coupled with a fan to make sure this smoke is extracted from the environment to guarantee the safety of whoever is in that place, okay? In terms of codes and standards, there are several standards existing in different countries and different regions. So here, of course, I will not go through all of these standards. There are much more than this list, okay? Usually these standards in terms of safety, they start more to the governmental or infrastructural side. So if you want to construct a building or a shopping mall, then there is an overall safety standard for it. And then you have more specific standards, some European standards, North American standards. But today I will focus on the EN 12101-3. Okay, this is the main standard, at least for us here in Middle East and Europe, right? Which specifies the criteria for the fan selection, fan design, the motor selection, motor design, and how these two are tested with each other together, right? So moving to the smoke extraction motor, the features of the smoke extraction motor from WEG. The beginning here, it says basically what I told in the beginning of the presentation. These motors are essential for ensuring the safety of people and environment as well, buildings, for example. And the design is fully based on EN 12101 standard. Okay, so we can classify these motors in a few different types, I would say, based on which temperature it needs to support for a specific amount of time, right? So the most common temperatures we have are 200, 250, 300, or 400 degrees Celsius for up to 2 hours. Okay, so the smoke extraction motor, the main difference between this type of motor and a standard motor from any stock, for example, is that a smoke extraction motor needs to be suitable to operate for 2 hours at an ambient temperature of up to 400 degrees. Okay, so now you can start and imagine the engineering challenges behind this. Even when you jump from 300 to 400 degrees, it starts becoming very severe in terms of the internal temperature, because at the end we have to guarantee at least for 2 hours that the motor will be able to run the fan. Okay. Looking at specific features now. So the number of phases of our motor is 3-phase for this case, mainly because single phase motors, they require the use of capacitors, and usually capacitors cannot support such high temperatures, right? So in most of the cases, what we see are 3-phase. In the power range, we can go up to 900 kilowatt, starting from the small ones, number of poles, 2 poles and higher, but mostly from 2 to 8 poles. Frame sizes, according to IEC standards, we can go from frame 80 up to 450, okay? Then there is a huge combination of possible voltages and frequencies. These we can customize as per what our customer needs. The fire rating, which is the point I was talking about, these are the different ways where we can classify our smoke motor, right? Efficiency level, we can have efficiencies up to I4 in this product line. So we see an increasing demand of higher and higher efficiencies, and this line, as all other lines of WEG, are following this trend, all right? Speed, we have single and double speed. I will explain this a bit more in the next slides. And the other points are actually explained more in the next slides, okay? In terms of mounting design, there are 3 main configurations that we can find in the market, or at least in the requirements from the market. So the first one is what we call B3, which is the foot-mounted motor. The second one is B5, which is no foot but with flange, so it's mounted with the flange. And the third one is pad mounted, okay, which it doesn't have a flange, it doesn't have foot, but it has these small surfaces here with threads, so that the customer can assemble, the fan OEM can assemble in their structure, okay, in the fan, inside the fan structure. So the first point here, it's a bit obvious, I would say, but it's important to mention that the motor will adapt to the design of each fan. So we have customers, for example, who have fans of these 3 types. So we need to supply more than one type of motor to the same customer, right? As standard, this line is supplied without the main terminal box. So if you see here in the bottom, we can see that the motor is supplied with a base plate, with a thread, and then we can supply the extended leads so that it can result in a design similar to the one you can see in the picture, at the bottom right corner here. So in this picture, this is just one example, okay, of how the motor is mounted inside a fan. So in this case, the fan, it has a steel base where the motor can be mounted with the foot. So it's a B3 motor. And then on top, we have this threaded base where the cables are being routed inside a conduit, which is also suitable for high temperatures. And it's conducted until the outer part of the casing, until the part where they can actually put and mount a terminal box, which will not be exposed to the hot air, okay? Uh, about speed, I will just go quickly here in this slide. We have options to supply single and double speed motors, right? And in double speed, there are two main variations where you can have independent windings or what we call Darlander connection or Darlander winding. For independent winding, the name itself says what it is. So it says if you had two different windings inside the same motor, and then with this combination, you can have um, association of poles, which is they do not talk to each other. Let's say so you can have, for example, one speed is two poles, the other one is related to six poles, while in Darlander um, it's in a ratio of 2 to 1. So you always have to, the speeds are always, one is twice the other. So it's like 2 to 4 poles or 4 to 8 poles. Um, in the table here, just showing one example of a standard table from our catalogs, showing a W22 smoke extraction motor with fire rating of F400 2 hours, frequency 50 Hertz, just as a reference. And here we can see the options we have as standard of double speed motor. So taking the first one in the frame size 80, the same motor is suitable for 0.15 kilowatt at 8 poles and 0.6 kilowatt at 4 poles. So this is how the designation exists. And but of course, double speed motors, they have some advantages and disadvantages, right? The biggest advantage is that you don't need a separate system to control the speed of the motor, right? You have already a motor which is suitable for two different speeds. However, these motors, as they are not fully optimized for one of these conditions, usually they are not able to reach higher efficiencies, such as IE3, IE4. Sometimes they are even lower than IE2, IE1. So the advantage of single speed motors is that you can have much higher efficiency. So in the long run, you will save more money, right? And you can also couple this motor with a variable frequency drive, for example, where you can play with the speed. Okay. So a bit more about the cooling method of the smoke extraction motor. So in general, right, the concept of an electric motor, it causes the motor to heat because of mechanical and electrical losses. Okay. And there are some main types of cooling methods for the motor, because with all this heat being generated, you need a way to expel this heat or to exchange the heat with the environment. Okay. The first and most common cooling method that we can find is what we call TEFC, or totally enclosed fan cooled, where the motor itself, it has an external fan which is part of the motor, which is coupled to the motor shaft. And when the motor is turned on and the shaft starts rotating, this external fan is the responsible for moving the air so that it can go all over the motor fins to guarantee a proper heat exchange with the environment. Okay. For the fan and exhaust motors or the smoke extraction motors, the most common cooling method is what we call TEAO, or totally enclosed air over. The TEAO design, it's more like if you are going to the obvious side of the application, because in this case, if a motor is driving an application which is actually a fan, it's not necessary for the motor to have its own fan, right? Because you already have a fan which can guarantee a much higher air velocity or airflow over the motor. So this is what we call totally enclosed air over. The motor itself is not designed with a fan, with an external fan, but the airflow or the heat exchange is guaranteed by the customer's application, right, by the load itself. So imagine you have a motor, normal motor exposed to an ambient temperature of 25 degrees, which is, or 50 degrees here in the Middle East. The motor will generate heat, and this heat will tend to be transferred to the environment. Okay. When we check the behavior of a motor in the normal situation where the motor is hotter, the temperature of the motor is higher than the temperature around the motor of the environment, we have the following temperature profile. So with a cross-sectional view of the motor inside the stator, we have the highest temperature, which is here in the windings, okay? Then there is an insulation material around the windings where it drops the temperature here. So which the purpose here is actually to insulate and protect the winding. Then we have the laminations. So you have conduction here, a heat transfer through conduction. Then it reaches the frame and the fins, where the purpose is to transfer the heat through convection. Okay, so the air will be flowing here over the fins, and then at the end the temperature will drop to the level of the environment. Okay, so when you have an environment at 400 degrees, even if it's just for 2 hours, the situation becomes exactly the opposite, because now the hottest part of the equation is not the motor, it's the environment. So the heat is actually coming from the environment to the motor. Okay, this is extremely important to know, because at the end the health of a motor is defined by the health of its insulation and the winding system. Okay, so in case you have too much heat coming through the windings, the insulation material will start degrading, and at the end your motor life will decrease drastically. Okay, and maybe it won't even support the 400 degrees for 2 hours, for example. So here we can see another chart which is very interesting, which can show exactly this concept of opposite, right, between the smoke and the normal motor. Because when we evaluate a standard motor, not smoke, at normal ambient temperature, if you have a higher air velocity over the motor, in general this is good, right? Because then it's in favor of the heat exchange. You can exchange more heat, you can remove the heat from the motor. But in smoke, it's exactly the opposite. So imagine you have a lot of hot air going around the motor. So if the speed increases, if you have a higher air velocity, it's actually worse. The motor inside, close to the windings, for example, if you consider the same amount of time, let's check this first dotted line. The red line, which is the higher air velocity, we can see that the temperature increase reaches a much higher value than at a lower air velocity, considering the same time. Okay, so that's why it's important to understand these concepts. Also, because I will show a few slides about what are the most important parameters of the fan that can impact in the success of the test, because sometimes when a motor fails, it's because some of the parameters of the fan, maybe the fan hub, it's too big or too small, and everything can impact how quick this temperature will increase inside the motor. So, as standard, the smoke extraction motors from WEG, they are designed with insulation class H, okay? This slide I would really like to talk for minutes and minutes with you, because there is a lot to explain. However, unfortunately I need to go very quickly on this, but it's basically the insulation is a material that has a resistance to a high temperature, right? And we have insulation class H, which is the highest one, which is actually selected for the smoke motors to be able to withstand more. But the motor itself is designed to allow a buffer so that it doesn't heat too much inside the motor, as in a normal design. So if the motor is operating at a normal ambient temperature, even having insulation class H to protect the windings, we usually design motors so that inside the motor at normal conditions, it will not pass the limits of class B. Okay, so it's 2 classes below the insulation. So this difference, 130 to 180, you can interpret as a safety factor, more or less, because it means that even if our motor is operating close to its limit as per WEG's electrical design, it is still much lower than the limit of the insulation class. Okay, and this is essential for a good for guaranteeing that at least internally the motor won't be too hot, and it helps in the end with withstanding 400 degrees for 2 hours. Okay. As per the EN standard, it's mandatory to consider at least one class difference. So if we design a motor with class H, the insulation class H, the electrical design needs to be designed in a way where the temperature rise inside the motor will not be more than class F. Okay, this is the minimum that the standard expects. As you can see, there are several points which I mentioned which are important for the motors, but I spoke a lot about windings, about the insulation, right? There is also the impregnation process, the varnish that goes in the windings. So here I would like to highlight that the importance of the business model that WEG has to cover all these variables, because at WEG, maybe some people are not aware, but WEG, the paint used in our motors is manufactured by WEG. The varnishes, the wires are drawn by WEG. So when we have control over all these variables, it makes our lives easier whenever we need to develop a new line or whenever we need to certify a special motor with a special fan. So we can control all these parameters. We have all the quality aspects, and that's why it's very important to highlight that the verticalization at WEG plays a huge role in the success of the smoke extraction motors. Okay. A little bit about the internal capabilities at WEG. So about the R&D in our laboratories, we have an amazing team in Brazil, in Portugal. The team is very experienced. They are using equipment such as these ones below to test the aging, right, of not only specific components such as the insulation papers here, but also the complete motors. We have also the thermogravity analyzer. Let me just go to the next one. Here you can see one example of aging tests on the complete motors. The motorhead testing, where you can test the complete insulation system. We can also test the aging process whenever there is an application driven by VFD, right? And also when we have sample motors, for example, I will show how we designed a motor which is for a test, okay? I will cover, you understand a little bit more about the certification process, but for a certification process, we manufacture a sample motor which is used with the fan for the final high temperature test. So whenever a customer asks WEG for a sample motor for a test, WEG manufactures actually more than just that motor. Okay, we manufactured extra unit for internal tests, because we know the criticality of this application, and you know how important it is. So in the beginning, during the production, basically a routing test is done, okay, which is subdivisions here, winding resistance, surge test, high pot, and etc. But after production, we run another routing test, then a complete type test, including temperature rise, vibration, and so on. We have a noise facility test, an acoustic chamber, and at the end, this extra unit manufactured by WEG is submitted through a high temperature test. Okay, but how? How can you simulate a high temperature at your factory, or how is it done? Then here you can see some pictures of the facilities that we have at WEG. Okay, so some of them are, for example, a dynamometer to test the motor under a load. Okay, we have a noise test facility, acoustic chamber, and the most important facility for the smoke motors is the high temperature test. And at WEG we have our own furnace, we can reach temperature up to 500 degrees Celsius. Okay. So here you can see the structure, how it works. We have a furnace, we have the motor inside. There are some pictures where we'll be able to see it better. Then you have the bearing loading here and the dynamometer to simulate the load as if it was the fan. Okay, and this method is actually allowed as per EN 12101, okay, NXD. So one way to certify a motor is to test with the fan, and another way, as per NXD, is to certify with this type of setup with a dynamo. Okay. A few more images here to show more capabilities of WEG. Just before I talk about the ones on the left, you can see a more detailed image of the motor inside the furnace. And on the left side, the whole numerical analysis that is done by our R&D team, not only covering the specific airflow for that fan, but also covering the simulations of what will happen with the motor and the fan inside the furnace. Okay. So the certification process, I think it's the most important part of this webinar. It's to explain how you can certify if the fan OEM wants to sell a smoke